Okay, good. Okay, so good. We're off and running here. So excuse me. So I did create the test last night, and it should be here. There it is. Scroll down. Now it says October 12th. I kind of give some flexibility because um, sometimes I know things happen. So that to ensure that everyone had access, timely access, I put the date as October 12th, but you do it tomorrow, and you'll see here it says test number one. Okay. When you go in there, I think it's, if I remember right, it's either 9 or 10 questions, or it's like 10 questions with an extra part, so 11 questions, or 9 questions with an extra part. So, and the extra one is just, it's an inequality. You have to graph it, graph the solution. So, and it covers, all I did is I just took the lessons here and I took one from each lesson just to kind of give you a heads up. So basically, what we've been doing in terms of the review is exactly the sort of thing that you're going to be doing on the test. And I would probably also say not as hard. I mean, I got some in there where you're going to have to work with some negatives. Sure, we have to do that, but it's not going to be every single problem like that. So yeah, I think you're going to find it's doable in 90 minutes. I think you're going to find it's doable in 60 minutes. You know, if I'm uh, candidly, because I didn't make them terribly challenging. I want to see that you know the skill, and I also know that sometimes working online and doing that is can be a chore. So kind of try to accommodate that. But basically, 10 questions is what you're dealing with. Excuse me. And what I do encourage you to do is once you complete it, take a screenshot so that um, in case something happens, you can have that. I received a couple emails. I can see. I checked my email before. I didn't respond, but I think a few of you all mentioned that you're not seeing your grades in the grade book. So take screenshots. Go in there, say, hey, look, on and Hawks, take a screenshot. Uh, whatever lesson we're on. Say 1.6. Here's my grade for that. The screenshots help me because I can then go in like I did with Jackie. I can go in and then just manually enter the grade. So, but I need to have something to be able to do that. So if that's you, take screenshots, send it to me. Uh, now I don't think it'll show on my end, but let me try to do view a student. So when I hit grades over here, let me see if it does it. So notice for me, it doesn't show any scores. It doesn't show any, I mean, it has a 0 right there actually for me, but it doesn't show any scores. So that's what you want to do over here is check your check your grades over here, make sure they're transferring over. And if they're not, then you know which ones you need to go make a screenshot of. That's sort of what you want to do. Okay. Before we begin, let me also kind of go back. Do this. Where is it at? Bear with me. There was one that we needed to review. This one right here. Let me go to it. Go to this. Share this. Okay, so this was the last problem that we had. Let me kind of let you all walk me through. This was the last question, that skill set. So if you haven't submitted the skill set, that's okay. Get your answer here and make sure you submit it into the Math 88 part of everything. But anybody want to take the first step here? What do we now? Let me make one special note here. Is notice the directions. The directions say simplify, and you have variables. So when you're talking about simplify and you have variables, you want to apply combining like terms. And if you have parentheses, you would apply the distributive property. So just to kind of give you a heads up, you're not doing order of operations or PEMDAS. You're not doing add the opposite. You're doing combining stuff together to the extent you can. Okay, so that's the setup. So how do we get rid of these parentheses? We got to get rid of the parentheses. Those are the barriers. What are we going to do?
Distribute.
Okay. So how about the first part?
distribute -8 to the x and the -4.
Okay. And so then, Addie, you get the pleasure of telling me what that is. So she's doing that right there. -8 into there, multiplying here.
Right.
So what do you get?
Um, -8x plus 32.
Plus 32. That's good. So this -8x here times this -4 here will give me a plus 32. That's the test, if you will. That's one of the tests. So right, -8x plus 32. Okay. So then what's next? How do I get rid of this parentheses over here? Can I just drop it?
Distribute the negative to the 5x and the
Yeah.
7.
So am I just taking the negative, or what is it really that I'm
It's
doing?
technically a 1.
Yeah, see,
So
it's technically a
-1.
-1 sitting in front of there. That's that's
Right.
that's the big test, if you will. So just like before, take that -1 and multiply it to each term on the inside. Okay, so then that gives us where are we at? Like, so it becomes -5x, excuse me, and then minus 7. Parentheses gone. Now we can bring things together. What you got? Like terms. Any like terms that I can bring together?
Yeah.
You would combine the -8x and the -5x.
Hmm. To get what, Gabby?
-13x.
Right. So we're combining the -8 and minus 5. So we're subtracting, and that's just going to give us the -13. That's exactly right. Negative
You could
13.
also do the positive 32 and then -7.
Right. Exactly right. So plus 32 minus 7 gives us, who was that? Was that Lola?
Yeah, it was me, and I had to pull out a calculator because I have no clue what that is off the top of my head.
Music,
Lovely.
music to my ears. Good. Check your work.
25.
Plus, you said 25?
Yep.
Yeah, good. Boom. That's right. Okay. So, one of the takeaways, and this will help you if you have to take other math classes too, but connect the direction with the process. Simplify all numbers, order of operations. Simplify variables, combine like terms, and maybe distributive property to get rid of the parentheses. Evaluate means what? Let me go back over here. Evaluate means they're telling you when you see the word evaluate, they told you what the variables are. So you just plug them in for each of the variables and then apply the order of operations. And then solve, you'll see something like this. Oops. Solve. When you see the word solve, whatever you have, you're going to see an equal sign. Okay? Something like this. 2x plus 1. Oops. Of course. Equals, I don't know, 9. Okay? So solve here means you're going to have that, an equal or potentially, oops, yeah, messed it all up. I messed it all up. Or you could possibly see an inequality. Okay? When you see solve, you'll either have an equal sign or an inequality. And so that's where you do add the opposite, do it to both sides, things of that nature. So we'll finish with that at the end, as we kind of wrap up with our review, just to kind of give you a heads up. Okay. So let's press for. Well, let me check in with you. Anybody, any questions? Burning questions right now?
I do have one simple question. So when you have an absolute value sign, and there is a negative in front of it, does it work kind of like parentheses to where you apply the -1 to both terms inside of
Wait,
the,
say it again.
sorry.
No.
When you have an absolute value sign,
Uh-huh.
and there are two terms inside or however many terms inside, but there's a negative sign, -1
Outside.
outside of the absolute value sign. So you
Right.
kind of like with parentheses, do you apply that negative to each term inside of it?
So here, let's do this one.
Okay.
Remember on this one, when we plugged it in, we got what? -5. So you want just a plain minus sign?
Yeah, I mean, -5 is good. That, yeah, it does the same.
So let's do something like -2, -3, minus absolute value 2 -8. Okay. So it's just a different problem. So keep in mind the absolute value is an operation. If we treat it like a parentheses in terms of when do we do it in the order of operations process, but at the end of the day, it is an operation itself. So once you get it down to a single number in here, then you have to apply the operation, um, the absolute value. You have to apply the operation. Okay, what is the absolute value of that -6? And so
It's
yeah,
six.
it's +6, and then this minus sign right here just gets detached to the
Okay.
front. Cool?
Yes, that
Okay.
helps a lot. Thank you.
All right. Oh, there. Back here. Nope. Share. Here. Okay. So, okay. So we are, where are we at? Oh yeah, we were looking at factoring. Factoring. Okay, let me see. Oh, so I was actually doing, so let me look, so the factoring I was doing, the interesting thing is the steps I was showing you for all of it is actually this right down here, the greatest common factor in grouping. So we're gonna finish that, okay, and then we'll jump back up here to do uh, to do those lessons as well. So we can kind of move it around as well. By the way, this test one does not include rules of exponents. That's that's going to be the next test, just to kind of give you a heads up. Okay, so let's finish up the factoring part of it. And remember what we were doing. What were we doing? Oh, I closed the document, so let me get a new document open. Let's see if it'll open. Yes. Bear with me, sorry. There we go. Okay. Make it big. Okay. So the thing we were doing yesterday is we had something, we looked at the process for finding, for doing prime factorization. We looked at the process for finding the greatest common factor when you have numbers and variables and even numbers and variables. And then we took that and said, okay, now that we know how to find the GCF and now that we know how to do the quotient rule, let's go ahead and put that together. Let's do a mashup and see how we um, uh, factor by way of the greatest common factor. And so remember the process for GCF factoring. Remember that was step 1, find the GCF. Step 2, place the GCF on the outside outside of a set of empty parentheses. Step 3, divide each term by the GCF term in the original problem by the GCF, then apply the quotient rule to simplify each division and place quotients inside the empty parentheses. Okay, so that's our process for factoring. So let's keep going with it. We saw an example, so let's do another example along to help us out. So something a little more complicated. So I think the one we did was sort of kind of basic. I think we did yesterday 2x to the third plus 8x to the fifth, something like that. The GCF in this case was 2x to the third. And so what we did is we divided each one, took the original two terms and divided each one by that GCF. Did that right there. And so we did the quotient rule. We simplified each expression utilizing the quotient rule that we learned the other day. So when we do that, this one here, that reduced down to 1. And then this one here, how did we do that? Well, 8 over 2 is 4. Quotient rule, x to the 5 minus 3. And so then that gave us 4x squared. Well, positive 4x squared. Where'd the positive come from? Right there, that plus sign in front of the 8. And so then we put in 1 and then positive 4x squared inside. So really all you're doing, the main piece of this is that you're finding the GCF and then applying the quotient rule. That's the main components. So this is one thing that you would do. Let's build on this to get some bigger examples, some more complicated examples. And so we'll pick one here. What? Oh, 12 x to the third, y to the fourth, minus 18 x squared, y squared. Why not? Okay. Nope, I don't like that one. I don't want to do that one. Y to the 7th. I'm just picking something. Okay. So step 1, find the GCF of the two terms. So you focus here when you're finding the GCF, you just focus on the 12x, these parts. So what is what's the GCF between 12x to the third y to the fourth and 18x squared y to the 7th? So first, find the GCF between the 12 and the 18. What's the GCF between 12 and 18? What's the highest number that goes into both 12 and 18?
6.
It would be 6, right? Oh, so how about the variables now? What variables are common and what exponents do I use? So remember with the variables, you look for what's common. So what variables appear in both terms?
The x and the y.
X and the y. Then you focus and then you hone in. Okay, look at your x's. What's the smaller exponent over the x's? You look at the exponents of the x's and you choose the smaller of those. And that's going to be 2. So with that in mind, what exponent do we use over the y? 4. Yeah, exactly right. That's it. Find the GCF of the numbers in front, see what variables are in common, then choose the smaller exponent over those variables. That's step 1. Then we then just place, write an empty set of parentheses. Okay. And now step 2 is take that GCF you just found right here, take that 6x squared y to the fourth, take that GCF and divide each term by that GCF. I'm going to do, and here I capture that minus sign, okay? I capture that sign in front. Okay. Quotient rule time. Let's simplify this one, the first one. 12x to the third y to the fourth over 6x squared y to the fourth. What does that give us? Well, 12 over 6 simplifies down to what? Any takers? Yeah,
2.
2. Okay, how about, oops. How about the x to the third over x squared?
One. Do you subtract?
You do. Subtract what?
Uh, 3. Subtract 2 from 3. So you'd have just 2x.
So 3 minus 2. X to the 3 minus 2 power. We're applying the quotient rule. What do we
Right.
do with the y's here?
Oh.
Don't we do the same thing?
Yeah.
Yeah, yeah.
So y to the 0 power would just be 1? Like,
Right. So
what do
yeah,
you do?
let's go ahead and clean this up. 3 minus 2, we know what that is. That's going to be 1. And because it's 1, x to the 1, what do we do with the 1? We can just drop it because it's an exponent of 1. The y, you're right. We do y to the 4 minus 4 power. That becomes 4 minus 4 becomes what? Y to the 0. And what's the rule for y to the 0? How do we simplify that part? It becomes, so what becomes 1? This thing right there, you erase the y to the 0, and that becomes 1. So remember, it's times 1. So then 2x times 1 is just 2x. So my point is, one of the things to take away from this, when you have the same thing in the top and bottom there, they'll cancel. They'll cancel. So the y to the fourth here, we could just get rid of it because they're the same thing in the top and bottom. Do y'all see that? Or any questions about that? Okay, so then
Could you say that one
you,
more time? I apologize.
say it again.
Could you say that one more time? I'm sorry.
No, no, that's
The
fine.
cancel.
So just remember your rule over here, little sidebar. If I have the fraction 3 over 3, what does it reduce to?
1.
1, because it's the same thing in the top and bottom. In other words,
Mhm.
the 3 cancels with the 3. It's the same idea here. The y's, oops, the y's cancel with each other.
Okay.
Okay, but the reason for that, why do they cancel? Is because really, when you do it, it becomes y to the 4 minus 4, which is y to the 0, and that just becomes 1. So it just simplifies. It's the same thing that you got over here. It's 1. So this thing here does indeed simplify to 1. It's just we say it cancels completely. So take a moment now. You all do the other part. Just write it down on your scratch sheet of paper. You don't have to shout out your answer, but take a moment and simplify that one and see what you get. By the way, you should not get fractions or decimals. You should get nice whole numbers. Okay, how are we doing? Let's go checking through. Okay, so start off with the numbers in front, and I'm looping in that negative, okay? I'm looping in that negative in front of the 18. So this is negative 18 over positive 6 is negative 3. What do we do with the x squared over x squared? Yep, they go away. They cancel, right? Yes. So perfect. So no x's, those cancel. What about the y to the 7th over y to the 4th? It becomes y
Subtract it.
to the 7 minus 4. So you do the subtraction of 7 minus 4, and that gives you the exponent of 3. Exactly. Then you take these things right here, and you just, oops, and you just plop it in to the empty parentheses, okay? So that's why I kind of do it right there. So I'm going to change my coloring to, this would be the answer. Oops. 2x, and then minus 3y to the third. So that's the entire answer. The entire thing in black ink at the bottom. 6x squared, y to the fourth, parentheses, 2x minus 3 to the y, 3y to the third power. And that's it. And by the way, it wouldn't matter if we had another term sitting over here. It doesn't matter how many terms you have with this. You know, suppose I had, 9, 6, x to the fifth, y to the sixth. I don't know. Just makes sense. It doesn't matter if we have another third term over here. You still do that. You do the same thing. You divide. You would divide this one. You would still divide this one by the 6x squared y to the fourth. Okay. So it doesn't matter if you have, it doesn't matter how many terms you have. This is the process. We're illustrating it with 2 terms, but just do know that you might have, I think you could see one in Hawks where they throw in like a third term, and it doesn't change the process. Find the GCF of the 3 terms, and then factor it out. Use the quotient rule to factor it out. So let me pause here. Any questions on the process? So we can use this process to our advantage, and now we're ready for the next type of problem. The next type of problem. We're still gonna do the GCF, but you're gonna see it's actually a little better in some cases. So let me do something like this. 2y squared parentheses x plus 1 plus 5 x plus 1. And the directions here, by the way, will say factor. Factor. That's the giveaway, how you know what you're doing. It'll say factor the following or factor or whatever it says. Okay. So how do we do this? Well, what you want to observe is looky right here. This thing, this parentheses, also appears right here. So the cool thing here in this particular case is that this thing, this x plus 1, is the GCF. Is the GCF. So there's no real going to search and find it out. This is it.
Is the x plus 1 the greatest common factor because there's 2 of them?
Well, no, because it's common to both.
Oh, okay.
Yeah, well, yeah. I mean, in a sense, 2 of them, 1 in each term, right?
Okay.
But it appears in both terms. So the cool part about this is that we don't really, we're still going to apply this process up here, but we really don't have to apply the process. This process still applies, but you don't really have to do it because it actually gets a little easier. So I'm going to find the GCF, but that GCF is nothing but that x plus 1 that's in the parentheses. That's the only thing that is common to both. Okay, so we pull that out. Step 2, write it next to an empty set of parentheses. Okay, I got that. Step 3 says divide each one by the GCF. So if we were to do that, we could do that. We could divide this by x plus 1, put it in parentheses. I could do that. There's nothing wrong with it. What you're going to end up finding is it's a wasted step, because then that thing cancels with that thing. Okay, so what happens? What happens is you're left with just the stuff in front. That's the result of all the canceling. So I don't like to go through all that rigmarole. It makes it a whole lot messy, doesn't it? So why not make it a little easier on ourselves? When you have this sort of setup where it's not just a single expression, it's something in parentheses, that's the GCF. All you have to do then is just focus on the stuff in front. Bring that in to the parentheses. Okay, so when you pull that, remember what factoring is. You're pulling it apart. When you pull the x plus 1 out from each one of them, all that's left is the 2y squared and then the plus 5. This is a little more straightforward. Questions on this process? We're going to do some more, obviously, but okay, so let's do another one. Let's do another one. So when you have, so the thing here, what we call this, by the way, I really didn't give it a name, but this thing here, it's called a polynomial, or in this particular one, it's called a binomial. But what you're looking for is something grouped in parentheses, stuff inside. It's called a polynomial. We'll talk more of that quite soon, actually. Okay, so let's do another one. Let's say 4m parentheses 6n minus 2, not 2, 7 minus 8, nope, not 8, gonna give me more work, I don't want to do that, not yet. 3p, don't let the m, n, and p throw you off. Try not to. I'm just trying to use, not get us so cluttered up with x's and y's. But what's the giveaway here? And it says factor, the directions say factor. Notice this binomial in parentheses appears in both places. Okay, so it's common to both. Common. So we can pull that common, what we call common binomial, we can pull it out. Pull it out. So we put 6m minus 7, or n minus 7 in front. Keep it in parentheses. And then just take the junk that's outside, the 4m and the minus 3p, and you put it inside. Giving us what? Not so bad, huh? Okay. So, your turn. Your turn. Let me do, the hardest part is really just making something up. So, let's see. X to the third, 2y plus 3 minus 2y plus 3. So take a few seconds, get it started, and see what you get.
Hey, so 2y plus 3 is the greatest common factor?
It is.
Okay.
So 2y plus 3 stays in parentheses, okay? So what goes inside the parentheses?
X to the third power minus 2.
Perfect. That's exactly right. How you feeling? Not so bad, huh?
This seems easy, so now it's gonna get harder.
I'm gonna throw you a little zinger. Yeah, I got it. I got to prepare you. You know. So let me do another one, and this one will have a zinger on it. So just to kind of give you a heads up, and you'll see why I was making corrections on my own. Like, no, I don't want to use that value. Let's do this. So let me do something like this. 4y squared z plus 3 minus 2x y z plus 3.
At the end of this class, Jordan's child is gonna know its alphabet before everyone else.
Yeah,
LOL.
well said.
Last time he was pooped out and he didn't even take the college class. He was out.
That's funny.
As if he went through the whole class.
So just like before, take that z plus 3, bring it out, and then what are we going to put inside? What will we put inside the empty parentheses?
4y2 minus 2xy?
Right.
Okay.
So the question is now, are we done? How do we know?
Since you're throwing that question at us, probably not.
Right. So what you have to do is whenever you're factoring, they want you to factor completely. So you have to look at them. Look at each parentheses separately, individually, and ask yourself, is there a GCF between the z and the 3 that you can pull out? Is there anything common to z and 3 inside that first set of parentheses? The answer is no, nothing in common. One has a z, the other one doesn't have a z, and there's no numbers in front. So nothing there, but take a look at this one. How about this part? Do 4y squared and 2xy, do they have stuff in common that you could
The
pull out?
Y's.
Y's, yes. What else?
Also, can you also zoom in on the 4 and the 2? So you'd have,
Yeah. So there's
Okay.
stuff. There's stuff that's common. So you got to pull that common stuff out. So essentially, you have to always look and see, is there a GCF I can pull out at the end? So what would be the GCF if we're honing in on this part, only dealing with that? What's the GCF between the 4y squared minus 2xy?
2y.
2y. And we're going to bring that all the way to the front. Okay? We're going to leave the z plus 3 alone, because remember, there was nothing that we could take out of that. But when we take a 2y out of here, what do we have left? So you got to come over to your scratch sheet of paper.
2x.
Close. Oh, yeah, well, close. Close. So you got to come over here and do your, oops, I'll get my different color ink. Remember,
2y minus x.
Yeah, you got to do your, yeah, that's exactly it. So you got to do your, take the 4y squared and divide it by the GCF of 2y, and that gives you 2y, and then minus 2xy over 2y leaves you with just a minus x. So then you put the 2y and the minus x inside here. And so even though we're pulling the GCF from this one, we pull that GCF and we place it in front. So the point is, and you will get tested on this in Hawks for sure. That's very common. I don't even have to look at Hawks. I know what they're gonna. I know they're gonna do it. At the very end, when you've got your factors, always just quickly ask yourself, hey, focus only on the stuff inside parentheses. Is there anything in common to the z plus 3? No. Good. Then look at the other set of parentheses. Is there anything common to both of those terms? Maybe so. Now, it doesn't always happen, but you want to keep an eye out for it because it is one of those, it's one of those things that if you don't check for it, it could happen and you miss out on the point because of it. So let me pause here. Any questions on this? Yeah.
Yes. So why did we divide 2y by 4y and negative 2y squared again? I'm sorry.
No, you're good. Remember, find the GCF, which was the 2y,
Okay.
and then divide each term by that GCF. So I'm dividing these by the GCF because that's the thing I'm factoring.
Okay. And so we're just focusing on the greatest common factor 2y and not z plus 3. I guess I'm like
Yeah.
figure out what do I need and what do I not need.
Mm-hmm. So you're just honing in on the one that has the common factors. That's the only one. The z plus 3 doesn't. So the
I
z
think
plus
she
3
trying
is.
to her question is like, so we found the GCF, which is z plus 3, and then we put that in the parentheses, and then you came with the 4y2 minus 2xy. So the greatest common factor in that is 2 because you can do 2 into 4. So that's where the 2 come from?
Yeah, yeah, this over here.
Okay.
The 2y, yes. This was pulled out of here.
So why did you leave the x out of it?
Why did I leave the x out? Good question.
Because there's no x attached to that 4y squared.
Exactly. It's
Okay.
not common. It doesn't appear here.
Okay.
And so, yeah, so just what I probably say it often too many times. Words have meaning. Greatest common factor. Use the phrase to kind of help you sometimes. So here it needs to be common. That's why we leave the x. We don't pull an x out, is because the x is not in both. It's just the y. That's a good one. I'm glad you asked that question because that's a point of clarification. I didn't do that on purpose. It just kind of happened that way here. Okay, so let me take all this. We're going to stay with this, but I'm going to erase this because I'm going to need some more room. Okay, I need some more room. So now what I want to do, was looking for, there you go. Let me make an example up. Bear with me. Okay, so actually I don't need to do this just yet. Let me make this big. 15xy plus 18x plus 10y plus 12. Yes. Okay, I want you to notice something here. How many terms do I have?
4.
4. When you see 4 terms, you should be thinking the grouping method. The grouping method only applies when you have 4 terms. Now you may still have a GCF, okay? We'll talk about that in a second. But when you see 4 terms, bing, 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 grouping method. Because that's probably what they're going to be testing you on. Okay, so how do we approach this? Well, what you want to do is you want to start off by asking yourself, is there a greatest common factor? Is there something that goes into all four of these terms? To be a GCF, it's got to go into everything. So is there a single thing that goes into both 15xy, 18x, 10y, and 12? Feels like it should, but there isn't. 2, I mean, this is odd right here. This one is odd. So 2 doesn't go into it. And there's no factor that goes into 15, 18, 10, and 12 simultaneously, apart from 1. Uh, this first term, 15xy, has a y, but this one doesn't. So y is not in it. This has an x, but this doesn't have an x, and this doesn't have any variables. So there's stuff common to some of it, but there's not anything common to all of it. So there is no GCF. What do we do? How can we factor this? Well, excuse me, I got an allergy thing going on all of a sudden. So what we're going to do is well, we observed that there's some stuff that there's some of the terms do have stuff in common. So for example, I notice, hey, if I kind of just put blinders on a little bit, oops. Yeah. If I put blinders on and think of your parentheses as blinders, it's kind of zeroing in on things, okay? Is there stuff that's common to the 15xy and the 18x? What would the GCF of that be if we just did that?
3x.
3x. So pull the 3x out. And so that leaves us, so when you divide, basically, you still divide the 3x here. What happens when I try to write real small? So take your 3x and you divide it to each of these. Not the other stuff, just the stuff that we're putting there, okay? So I can divide that 3x there. I'm just factoring out a GCF from that parentheses, okay? And then it leaves me with what? 5y.
Plus 6.
5y plus 6, right. Can I do the same thing to the other one too? What happens if I group this?
Then it's its own separate thing.
Can
The
I
same
put,
thing.
is
Yeah,
there a GCF here?
2 at least.
Anything more than 2? No variables, because one has a y, the other one doesn't have any variables. So it's just 2. So one thing first, there's a plus sign right here. There's a plus sign right there. It's kind of getting buried in the whole process. Okay? Don't forget it. So I'm going to bring it down. I'm going to pull a 2 out. I'm going to pull a 2 out. So a 2 goes here. So divide each term by the 2. And what do we get?
6. 5y plus 6.
5y plus 6. How does this help us? Well, looky there. Looky there. 5y plus 6. 5y plus 6. That's how you know you're doing it right. When you see the same binomial pop out all of a sudden. And so we did this. We know how to do this now, don't we? What do we get?
5y plus 6 and 3x plus 2.
Right. And then put the 3x plus 2 in front, in the other one. And by the way, you could write it 3x plus 2 times 5y plus 6. Well, voila, look at that. So what did we do? Okay, so kind of recap time. We'll do another one. We grouped the first, that's why they call it the grouping method. You put parentheses around the first 2 terms, you group them. You put parentheses around the last 2 terms, that's grouping those. And then you just pull the GCF out of those parentheses, hoping you get a common binomial, and then you pull that common binomial out. So essentially what you're doing is finding the GCF 3 separate times through the process. So 1, group the first 2 terms. 2, group the second 2 terms. And when I mean group, put parentheses around them. Second 2 terms. Pull the GCF out of the first parentheses. Pull GCF out of the second parentheses. Pull the common binomial out. Finish the problem. So that's it. Let me do this. Group the first 2, group the second 2, pull the GCF, and then pull that common binomial out. It's not terrible. It's just, it takes a little practice. So let's do another one, and you'll see the process now. So here we go. Okay. Okay. xy minus 6x plus y minus 6. So step 1, group the first 2 terms. Parentheses around the xy, and then parentheses after that first 2. That second term, I mean. Step 2, put parentheses around the second 2 terms. Notice where I put that parentheses. I put it between the plus sign and the term. Okay, I cut it in, I separate them. More to come on that. So now I want to find, look at the GCF, look at the first parentheses. What's the GCF between x, y, and x?
X.
X. So when I pull an x out, what's left in the parentheses?
Y minus 6.
Y minus 6, right. When I pull an x out, leaves the y. When I pull an x out, leaves the 6. Okay, bring down that plus sign. Is there a GCF here that I can pull out from y minus 6, the second parentheses?
Doesn't seem like it because you can't do 1. And there's no constant attached to that variable, so other than 1.
Right. So that's right. That's it. That's it. So there is no GCF out of that one. So there's nothing to do. But notice what we have is we have the same binomial here, the y minus 6. That lets us know, that gives me the feel goods. I got the feels from this. Yes, I'm in good shape. So now what do I do? Take that y minus 6 and I put in by an empty set of parentheses. The question is, what goes inside?
X plus 1.
Whoa. Where did that 1 come from?
There is, as you said before, whenever there's parentheses okay, I'm getting my logic from the distributive factor mostly,
Right.
and how if you don't see a number in front of the parentheses, there is always an invisible 1 somewhere that comes out just like a stalker. Just like, hey, I'm here.
Don't forget about me. So we take the x from in front here, and we take the plus 1 there. Don't forget, there is a 1 there. There's got to be something there. Because when we pull this, so think of it this way. When you pull this out, something's got to stay behind to hold its place. The 1 is there. The 1 is there, holding its place in line. How you feeling? Okay. I'm going to take this exact, remember the original problem, by the way. I'm going to come up here and write the original problem. Okay. I'm going to change it up a little bit. Okay. Instead of doing that, I'm going to change these two terms right here. All I'm going to do is just switch the order. Still the same problem. Still the same problem. So what I want to alert you to is because it's the same problem, we had better get the same answer. Okay? But I'm alerting you, we're not going to get the same answer. Okay? Don't write your notes yet. Okay? Just kind of maybe more of a watch this time. Okay? So what's our process? We can still apply the process though. What's our process? Parentheses around the first two terms. Parentheses around the second two terms. Good? Okay. Then what? What's the GCF out of this one? Out of the first set of the parentheses?
Y.
Y. What's left behind when I pull a Y out of here from each one?
X plus 1.
X plus 1.
Perfect. Bring down that minus sign in between. What's the GCF out of this right here? What's common? What appears in both?
6.
6.
6. When I pull a 6 out, what do I get?
X minus 1.
X minus 1, right. So I pull a 6 out of here, left me with an X. I pull a 6 out of 6, leaves me with 1 hanging back. Now, this is the stage where you want to check yourself, okay? You know you're doing it right when you got the same binomial. Are we doing it right?
No, we're not. One is one. X plus 1 does not equal X minus 1.
What in the world? We should be getting the same exact answer, but now all of a sudden we're not. Something happened. What's the only difference structurally between this problem here and this problem here? You don't have to answer that question. I'll tell you what the answer is. It's that minus sign right there in front of the third term. Because look at what we do. When we take this parentheses here, we put it in between the value and the sign. That's okay when it's a plus sign because it doesn't change the sign. But what happened when we did it here? We took this, you're treating it as a minus 6x, but now all of a sudden it turned positive because we chopped off the negative. Uh-oh, that was the problem. Essentially what we did is by taking by putting this parentheses there, we didn't realize it, but what we were actually doing by doing that is we're pulling a negative 1 out. We're pulling a negative 1. We didn't see it. It's like a magic trick, but that's what happened. That was the net effect. So the point of all this, the point of all this is that when your third term is a minus sign and you put a parentheses in between it, you have to change the sign of the last term. So this sign of the last term changes what? From minus to what?
Plus.
Plus. And so when we do that, oh, look at that. It fixes it all. And now we got the same thing. You see that? Now we've got x plus 1s in both. So what do we get? Pull the x plus 1 out. What's left? Y minus 6. Yes. Now they're the same. Now they're the same. So this is the key thing here. When your third term is minus and you put that parentheses around that third term, you got to change the sign of the last one. Change it to the opposite. If it's minus, turn it plus. If it's plus, turn it minus.
Wait, hold on. Could you explain that a bit? So whenever you have a minus sign in the middle of it and only a minus sign, whenever you put parentheses around the third term, that's when you change the sign in the parentheses?
Yes. That's exactly it. We'll see it again. We're going to do another one. But I just wanted to set you up with that.
I just needed clarification because I couldn't hear earlier because currently my mother is packing stuff in our room. So,
I hear you. Okay, so let's see this again. But we're going to do a little bigger problem now. So bear with me. Okay, so I'll just keep it simple. 8xy minus 10x squared minus 15xy plus 12y squared. Okay, hold on. I'm going to put those as squares. Where'd you go? Oh, I'll just do this. Okay, so 8y squared, I'm sorry, 8xy minus 10x squared minus 15xy plus 12y squared. Okay, copy and paste that. So parentheses around the first two terms. Parentheses around the last two terms. Okay, but because this third term, because I'm chopping up the minus sign, I have to change this last sign right here. Do y'all see me highlighting it? That one has to change from plus to what? Minus. Are we good with that? Now we take out the GCF of each. So the GCF of this one, 8xy minus 10x squared, is 2x. Yes. So when you pull a 2 and an x out, you get 4y. And a 2 and an x leaves us a 5x. Bring down the minus. Now what's the GCF here? Looks like it's
3x. Nope, 3y.
3y.
Holy crap.
So out of the 15xy, pull a 3 and a y out, leaves us a 5 and an x, minus, pull a 3 and a y out of here, leaves us a 4 and a y. I did something wrong. Hold on. Oh, I know what I did, because
I'm sorry. Does the middle sign change to positive?
No, I don't think the middle sign changes to a positive sign. I think it just tells the other sign after it to change.
Uh, okay. I see what it is. It is right. It is right. These don't look the same, do they? Oh, I see why I did that.
I mean, they have the same numbers and the same variables, just
How about
not in the
this?
same place, which technically messes it up.
It does. It does. Let me do this instead. I'm going to redo it.
Can you just switch the place of the 10x and the 8? Can you just flip flop them in the beginning and then it would turn out right?
The answer is yes.
Okay.
Okay. There is a way around this, by the way. There is a way around this. So let me do this up here. So if you ever get locked, if you ever get this result here, notice what's the difference between the two? The order of subtraction is just flipped. One's 4y minus 5x, flip it, 5x minus 4y. When you have that circumstance, that just means the signs are different. Over here, this one's a positive 4y, this one's a negative 4y, this is a negative 5x, this is a positive 5x. So really they are just sign differences. So when you have this, what you can do is just pull a negative 1 out from either one, not both, but one of them. And when that happens, you end up switching the order of the terms. So if you ever find yourself in that situation, you can just pull out a negative 1 from one of them, and that resolves the whole issue. And so we're left with it's getting a little much. So it's getting a little much. Let me do the one that I actually intended. Uh, do this. Take this. Yeah, now it's going to work. Okay, let's do this. Just switch the middle two terms. It's the same problem. It's just a little, the order's different. So parentheses around the first two. Bear with me. Parentheses around the last two. But because this middle sign here was minus, we have to change this one, change it over to plus. Now pull the GCF out. GCF out of 8xy and 12y squared is 4y. I pull a 4 and a y from 8x, I'm left with a 2 and an x. I pull a 4 and a y from 12y squared, I'm left with a 3 and a y. Okay, good. I can see my answer. It's good. Now, GCF out of 10x squared plus 15xy is just 5 and an x. So I pull 5x from here, I'm left with 2 and an x. I pull a 5x out of here, I'm left with a 3 and a y. Ah, there we go. It's the same thing. So 2x plus 3y, parentheses, 4y minus 5x. So my apologies, I didn't account for my sign when I was flipping it in my head and I just forgot to flip it again. So The point here is that you just want to be mindful when that middle sign is minus and you put that parentheses in, you got to change the sign of the last one too.
Okay, question.
Mhm.
So, do the two questions or the two polynomials in the parentheses always go first? Or could you put the 4y minus 5x first
Oh,
and
yeah.
then the polynomial?
Or 4y minus 5x, 2x plus 3y. Either or, it's fine. They're the exact same thing.
I'm just asking because the second way makes more sense to me because of how I read it. So,
Sure. I hear you. I hear you. So yeah, that's a good question because it does pop up every now and then that I get something, you get something different, but they really are the same thing.
as with math, you always have to ask, what can I change? What can I change how I write to make it better for myself?
So
Huh.
let's take a look at then, where was I at? So this was section 3.4. This material we've been doing with factoring is section 3.4. So let me see if there's anything that I haven't talked about. Four terms right away. Oh, it tells you, look, grouping tells you, if you got four terms, look for grouping. Yeah, there it is. The minus sign in the middle. So it's going to get you real early on. Now this one only has three terms, okay? So you would just look to see if you have a greatest common factor, okay? Three terms. Don't try to do the grouping method. Well, at least not yet. This here, this is you already know this. This is the quotient rule. Remember, simplify your numbers in front, and then apply the quotient rule to the variables 8x, x to the 8, and x to the 6th. Grouping method, there's four terms. So good. Find the GCF. Good. So we've pretty much done, yeah, we've done this. Find the GCF. So we've gotten you pretty well set up on this one. Good. With all the bells and whistles. Now here, same thing. It's just three terms. So you want to find the GCF. And on this one, looks like it's what, 2x, y. That's the GCF. And that's what you pull out from each one of these. My watch is going crazy. Okay, so this one's also factoring, by the way. Let's see. Let me check the other ones. Oh, greatest common factor. Yeah, you're finding the GCF between numbers. That's what that last problem was too. You're finding the GCF. Finding the GCF, you're factoring out the GCF. Just a little more piecemeal approach. Okay, so great. Ooh, that was good. So actually what we probably did some more harder stuff than what's expected of you there. So then let me go, we do have to kind of make our way through some material. Let me see what 1.3 is all about, because it doesn't really seem familiar. Oh, okay. So what they're doing here in section lesson 1.3 is um, they're asking you basically what's the essence of a polynomial. And basically a polynomial is of the form, we do something like this, ax, something like this, ax squared plus bx plus c. I mean, we're not going to make this terribly difficult. Whoops. We're not going to, don't write this down, is what I'm saying. But what I want you to see, when we talk about polynomials, what are we talking about? We're talking about stuff where the exponents are whole numbers, okay? 0, 1, 2, 3. So here, if you notice, this one has a fractional exponent, which is possible. We'll talk about those. But that's not a polynomial. It has to have a nice, neat number as your exponents. So this one in this particular case would be a non-polynomial. Would be a non-polynomial because you can't have fractional exponents. Can't have fractional exponents.
Fractions are everywhere, man. They're multiplying like rabbits. What the? Why?
So
Hate fractions.
this one would be a polynomial because look at the exponents. 5, 6, and the z has an exponent of? What's the exponent over the z?
1.
1. Good. So nice, neat numbers, no fractions, no decimals. Polynomial. So now, notice the directions here. It says add or subtract the polynomials. Okay, so take a step back. The study of algebra, in a lot of ways, is taking the rules of numbers that you learn. How do you add numbers? How do you subtract? How do you multiply? How do you divide? And just you take those rules and you apply them for every new thing you get. So you learned how to add, subtract, multiply, and divide positive numbers. Then what did you do? Add, subtract, multiply, and divide negative numbers. Then what did you do? Add, subtract, multiply, divide decimals. Add, subtract, multiply, divide fractions. So every time you learn a new thing, you learn the rules for add, subtract, multiply, and divide. It's the same exact thing here. Now our new number is a polynomial. That's our new unit, a new grouping, if you will, a new thing. Because keep in mind, variables are just, they're letters, but they're letters that are numbers. Okay, so all of our rules of add, subtract, multiply, divide should still work. We learn the product rule and the quotient rule and all that stuff to help us when we're trying to combine variable terms. Okay, so when we say add or subtract polynomials, really what we're doing is what? You actually already know how to do this. If you took your material, I'll show you that you know how to do this. Where is it? Where are you? That is two polynomials already. And what did you do? How did we solve that one earlier? Hattie walked us through it. Take the numbers in front, apply the distributive property to get rid of the parentheses, and then combine like terms. You've known this now for a couple weeks. And you're just doing it again, this time with more terms. But still the same process. You got these parentheses. You got to get rid of those parentheses. How are we going to do that?
Multiply by 1
What's
for
the
the
number in front? Exactly.
for the
There's a
first
1
set,
in
and
front
then
here.
-1 for the other set.
Exactly. And so when we do that multiplication inside, it becomes 5x to the 4th plus 13 minus 6x. And now we do the second parentheses. Minus 1 times 6, minus 1 times minus 9, and then minus 1 times 8x to the 4th. And then what do? Combine your like terms. This one is like this one over here. So that becomes negative 3x to the 4th. This one, plus 13, is like this one here, minus 6. So 13 minus 6 gives us plus 7. And then, where are we at? Minus 6x plus 9x gives us what? Oh, yeah, plus 3x. Voila. This lesson on 1.3 is stuff you already knew. We're calling it, all we're doing is we're calling it a new name. We're calling it polynomials. But it's still the same thing. Get rid of your parentheses using the distributive property and then combine like terms. And that's it. So So let me see. Oh, this one here says express the polynomial in descending order. The buzzword, the buzz phrase, is this one right here, descending order. What does that mean? Look at the exponents, and you write them from highest exponent to lowest exponent. Highest exponent to lowest exponent. So the term with the highest exponent is this one right here, 2y to the 12th. So you write that one first. Then the next highest exponent is the one with the fourth. So that becomes plus 3y to the fourth. Then the next highest is the minus 3, minus y to the third. And then the last one is the plus 9. Notice now the exponents are arranged, the terms are arranged so that the exponents go from highest to lowest. That's all that means. Descending power. But the trick here is what? What's the watch out? Where's the pitfall? If you were going to make a mistake, where do you think you would make that mistake at? That minus sign. Make sure you keep your signs attached. That's the trick with that one. But you've been doing that for weeks already, haven't you? Already. So again, we're not really showing you anything new. We're just taking some old stuff and calling it something new. Is this one factorable or is it not can it be factored? The answer is no, because only polynomials can be factored. Only polynomials. Are these polynomials? Is this a polynomial here?
Yes, because I'm not sure if my logic. Nope, actually, the exponent is negative, so
Negatives.
what, can't be. Okay.
Not factorable. Technically, you could factor it. There is a technical part of it, but for our purposes, no, not factorable. Hmm. Let me see what they say. I am incorrect. Okay, so it is factorable. I knew there was a thing. So this is a terrible problem. I don't like this problem. I think this is an unfair problem, is what I'm saying.
Lovely. That means we put everything under 1. 1 over 3x to the first power positive plus 11x to the fourth power also positive. Because whenever you put things on the bottom, everything switches.
I was about
Almost
to
there,
say
right?
you can go to
Let's
tutor and they'll show you.
let's take the x to the first and pull it out. X to the -1 and pull it out. We can do that. That's why I probably should have thought of that first. I'm like, yeah, you actually can pull this out. So here in this case, the GCF would be the x to the first power. Oh, I'm sorry, negative first power. So if I pull x to the -1 out, what's left? A 3 plus an 11. What does this become? It's supposed to be a question mark. Two bunched together. What is the exponent over here? Well, keep in mind when we're pulling stuff out, I'm going to go to my scratch sheet of paper. If you're going to pull out a GCF, remember what we're doing is we're really dividing by that. So I apply the quotient rule to do top exponent minus the bottom exponent. So -4 minus 1. And so that gives me 11x to the -5 power. So that's what that becomes right there. So how does that help us? Well, now I think I forget if it was Jordan or Lola. I forget who said it. But now at this point, apply your negative exponent rule. What does x to the first become? This is a mess.
Everything is a mess.
This is
Jesus.
I really hate this problem. I'm probably going to go in and try to take it out. This is a terrible, terrible problem. We never. So it flips. Remember, it shifts it to the bottom, and this becomes 11 over f. This is just nuts. This is not. Don't write this one down. I'm going to go in and take it out. I can tell you right now, this is not a fair problem.
Thank you.
But my point why it's not fair is because there's actually more than one way to write the answer and it all be correct. So, not a cool problem.
Can you go to the tutor button and solve it so that I can see what the solution is for it, just for this one?
Let me do this. Let me actually apply the negative exponent rule. I guess you could pull a 1 over x out. It's just nuts. What do they want to do? What do they want us to do? For this expression, the least exponent, I have no idea. -4. Okay. Next page. So they want you to pull an x to the -4th out. Now I see. Yes. Okay. So take the one. I was taking the least one. They want you to take. Yeah. They still want you to take the least because -4 is less than -1. That is right. Pull that one out. I see now what they want to do. Terrible. I'm going to take it out. So
Thank you.
this is nuts. So if you get to this, by the way, let me know. If I don't take it out by the time I get there, then please let me know. All right, so I'm going to go back to practice. Okay, so we're running out of time here, but basically that's all this thing is it's just, hey, is it factorable? Is it not factorable? Apply the grouping method, things of that nature. Is it a polynomial? Not a polynomial? Adding or subtracting polynomials is just what we've done the entire time. So, oops, skip it. We'll talk about trinomials in a second. This one is factorable. Well, that's interesting. Why do they have you factor polynomials when they haven't shown you how to factor polynomials yet? Trinomials, I'm sorry. Let me see. That's a terrible question too. I don't like this question because it's asking you to do it before they actually show you, before you've gone through the process of factoring trinomials. We'll do that. We'll do this one, but we're not going to do it yet. We'll get there. We'll get there.
Yeah, the bad thing about Hawks
Let me
is
say it
that
this way.
it kind of has a
I
bad
see.
learning curve
I see
because
this one. Let me interject. You can factor a GCF out. You can factor a GCF out. That's what you would want to do. Because there's a 3, an x, and a y. 3x squared and y that you could pull out. Okay, but my overarching point here is that this lesson for section 1.3 factoring, polynomials and factoring is actually, you actually know enough. You know, I'm going to try to take that one problem out with the negative exponent. But everything else you know. Is it a polynomial? You're looking for integer exponents, no decimals, no fractions. Adding or subtracting polynomials just means combining like terms, just like we've done already. So, not tomorrow, but Thursday we'll do this one, and we'll start looking at this one too.
Okay.
because those sort of go hand in hand. The special products and the special factoring techniques, those are recipes. That's actually what the cool part is about those is they are recipes. Once you see the pattern, you just follow the pattern. There's not really factoring; it's just pattern matching. So that's why we can probably do them all together. Okay, so before we take off here, I did want to do one more thing, just to kind of one last thing. Just let's suppose I have let's hope for the best. Okay, solve the following. Kind of get the juices flowing as you prepare for your test tomorrow. What would be my first step here as a review?
Parentheses.
And so, who was that? Jordan. All right, you're the big winner. So, what you got? Go ahead and take care of my parentheses. What's my next line? And everyone else, do it. You get rid of your parentheses. Write it down. Take a moment. Okay. So 5x remains the same, but we take that negative 2 on the outside and we multiply it inside. That negative 2 on the outside, multiply it inside the parentheses, and I get minus 8x minus 4. And I just bring down the 7. Now what? Parentheses gone. Good. Now what?
You do 5x minus 8x.
If they're on the same side of the equal sign, you can combine those terms. So what do I get when I combine the 5x minus 8x?
-3.
Negative 3x. And then bring
Yeah.
everything else down. Now what?
You add 4 to the 7.
Right, so I want to move the 4 to the other side of the equal sign. And remember, if you're going to move a term, you got to add the opposite. Okay, so I'm going to add 4, add 4. Ugh. Oh well, I didn't choose wisely. Okay, so yes, I got rid of that 4 by adding 4 to each side. Now what?
So,
Divide -3 to each side.
right, but it's going to be negative 3x equals 11, right?
Yeah, I was about to say, why do you have a 7?
Yeah, I think we just forgot to finish, but okay.
Oh, I just made a calculation error.
I do that all the time.
So what's our final answer then?
Negative 11 over 3.
X equals negative 11 over 3, right? And had this been an inequality,
You swap the signs for dividing.
everything would have been the same until the very end where I have to flip it. Because why do I have to flip it down here?
Because x is greater than negative 11 over 3.
Well, no, here's from when I was at this term, this was the term I had to flip it. What am I doing here that requires me to flip the inequality?
You're dividing by a negative.
Dividing by a negative. That's the word. When you multiply or divide by a negative, turn the inequality. That's the rule. So it comes at the end, is what I'm saying. I think that kind of circles back to, I think, question someone had: when do we do it? If it doesn't matter if it's an inequality or an equal sign, the steps are all the same until the very end. You ask yourself, dividing by a negative? No. Leave it alone. Yes. Flip it. Here we were dividing by a negative, so we turned it. And how would you write this? How would you write x greater than negative 11 in interval notation?
Negative 11 over 3 in parentheses.
Okay.
Or like you begin parentheses on the left side of 11 over 3.
Is that what you mean right here?
Yes, sir.
Okay.
Is that correct so far?
Well, I just want to hear your answer. Let's see. Let's go for it.
Comma. Infinity. And parentheses, since there's no or equal to symbol
That's exactly right.
in inequality.
All the way around.
So
Perfect. No changes.
good. And is it best to put the smaller number first?
What's the rule?
Oh.
Always put the smaller number first.
Okay.
And when you're in interval notation, yes, the
Mhm.
smaller number goes
Okay.
first.
You got it.
Okay, so we just reviewed 3 of the problems that are on the test, just with this one example.
Awesome.
So
Thank you.
You're good.
You rock.
All righty.
And the test is on Hawks, correct?
It is. And
88.
it's ready to go whenever you want. So we will not be live here tomorrow. You do the test whenever you want, tonight, tomorrow. Yeah, probably not do it tonight. You've done enough math. But we're not going to meet, just to kind of give you a heads up. Okay? And I'm going to post this video here too a little later.
Thank you.
All righty. Okay, well, good luck. You're going to do great. You know everything. I've seen it over the last 3 days. So I'm confident. You should be confident too. You do have 2 attempts. I did program it for 2 attempts, and it's going to take your highest attempt, your best
Thank
grade.
you.
So you're set up for that as well. All righty.
All right. We
Well,
appreciate
good luck. We'll connect in a couple days, and let me know if you have any questions in the meantime. I'd be happy to help out.
it. Awesome. Thank you so much.
Okay. You'll have a good one.
You too.
Thank you.